Core 2, June 2013, question 6. Hey, this is all about differentiation and using rules of indices. So we start off, we've got this curve, and the first thing it's asking us to do is express this curve in a different form. So we're going to take 12 plus x squared root x over x. Right, one of the first things we want to do is rewrite the square root as a power, so square root is the same as a power of a half. We've then got x squared times x to the half, so we can rewrite that as x to the power of 2 plus a half. 2.5 is the same as 5 over 2. Once we've done that, we've now got 12 over x plus x to the 5 over 2 over x. So I've done that, so we can now simplify the powers further. The way to write 12 over x is to bring the x up. If it comes up from the bottom of a fraction, it's a negative power, so that's a negative 1. And here we've got x to the 5 over 2 divided by x to the 1. When we divide, we subtract the powers, so it's 5 over 2 minus 1 is 3 over 2. Now we're going to need this answer for the next part, in part B, part 1. It says, hence find dy by dx. Well, we needed to rewrite it into index form so that we can actually find dy by dx. So now we can differentiate. To differentiate, we just drop the power in front, so that's negative 1 times 12, and we decrease the power by 1. Be careful when working with negative numbers, it's very easy to go the wrong way. So negative 1 take away 1 is negative 2. Also with the fractions, be very careful. So we're going to drop the fraction in front, 3 over 2. We're going to take 1 off 3 over 2, which gives us a half. Now we've done that, we're going to use our differentiation. So now we want to find the equation of the normal. Be careful, sometimes it asks for tangent, sometimes it asks for a normal. In any case, we need to use our dy by dx to find the gradient. So that will give us the gradient of the tangent. So we're going to substitute in our x value, which was 4. So we get negative 12 times 4 to the negative 2 plus 3 over 2 times 4 to the power of a half. And you can put that into your calculator and you'll find out that that's 9 over 4. That's the gradient of the tangent. So the gradient of the normal is the negative reciprocal. So it's going to be minus 4 over 9. When we're finding tangents or normals, we need a point on the line and the gradient. We've been told x is 4, we don't know what y is. So we go back to our y equation, which is the original. So y is 12 plus x squared times the square root of x divided by x. And that will tell us that y is 11. Once we've done all that, the easiest way is to use the form of the equation y minus the y coordinate is gradient brackets x minus the x coordinate, and we won't ask for a specific form, so that gets us the answer straight away. Okay, having done all that, we found the equation for the normal. We don't actually need that answer for part 3. B part 3 tells us that a curve has a stationary point. Okay, a stationary point is where the gradient is 0. So what we need to do is we need to take our gradient expression and make that equal to 0. So dy dx is 0. Okay, this gives us an equation to find out what x is. In order to do that, it's probably easiest to rewrite our x to the negative 2. That means really that it's divided by x squared there. So we've got plus 3 over 2, 3 over 2, x to the half equals 0. Don't like having x's on the bottom of the fraction, that's going to make that difficult to solve. So we might want to think about multiplying up by that x squared. So negative 12, multiply everything by x squared. 3 over 2 x to the half x squared. 0 times x squared will still be 0. Now I've done that, I can see I can move negative 12 to the other side. And then here I've got 3 over 2, I've got x to the half times x squared. We've seen before when you've got x to the half times x squared, that's x to the 5 over 2. Okay, so now we've got x to the 5 over 2. X to the 5 over 2, this was times 3 over 2. So that's the same as having 12 times 2 divided by 3. So we can get to x to the 5 over 2 equals 8. Okay, so at this point, we need to do something to x on its own. So what I can do to do x on its own is if I do to the power of 2/5 to both sides, on this side you'll end up with x to the power of 5 over 2 times 2/5, which is 1. So we get x to the power of 1 is 8 to the power of 2/5. Well, that's an answer for x, but it's not in the form required, which was 2 to the power of k. So what I need to think now is 8 is the same as 2 cubed. So if I rewrite 8 as 2 cubed, I've got 2 cubed to the power of 2/5. When we've got a power to a power, we're going to multiply those. So that's 2 to the power of 3 times 2 over 5.